What's up, math brainiacs? Welcome back to Arithmophilia. Don't forget to subscribe. For today's video, we are going to talk about the concept of polynomial equation and the zero product property. But before that, let us be guided of our objectives for today. The following are the things that we need to achieve at the end of this video tutorial. First, illustrate polynomial equation. Second, identify the types of polynomial equation. And lastly, find the roots of polynomial equation using zero product property. Without further ado, let's now start our discussion, starting with the definition of polynomial equation. What is a polynomial equation? A polynomial equation is an equation that has multiple terms made up of numbers and variables. Usually, it is expressed in the form ax raised to n, where a is the coefficient, x is the variable, and n is the exponent. Example of a polynomial equation is 5x raised to 3, plus 4x raised to 2, plus 2x, plus 6, equals 0. In this example, we can identify the following parts of the polynomial equation. First, degree of polynomial. It is the highest among the exponents on the equation. So, based on the example, the degree is 3. Second, leading coefficient. From the word itself, it is the number written in front of the variable with the largest exponent. So, we have 5 as our leading exponent. Third, constant. It is the term of degree 0 and the term in which the variable does not appear. In this case, our constant is 6. Polynomial equation can be classified according to its number of terms. We have monomials, which are algebraic expressions with only one term. For example, 2x, 5xy, and negative 3z. Next is binomials. These are algebraic expressions with two unlike terms separated by addition or subtraction. We have the examples, 2x squared, plus 3, x minus y, and 4ab, plus 2ac. Third is the trinomials. Trinomials are the algebraic expressions with three unlike terms separated by addition or subtraction. Examples: x squared plus 3x minus 2, and 2x squared, plus 4xy plus 2z squared. Polynomial equations can also be classified according to the degree of its exponents. First, as linear equation. This type of equation is in the form ax plus b equals 0, where a is not equal to 0. The highest exponent here is 1 or in first degree. Example, 15x plus 2 equals 0. The variable x has an exponent or degree of 1. Next, quadratic equation. This type of equation has a general form of ax squared, plus bx, plus c equals 0, where a, b, and c are real numbers, and a is never 0. The two letters, b and c, can be 0. Example, 2x squared, plus 3x, minus 12 equals 0. The third type is cubic equation, which has a general form of ax cubed, plus bx squared, plus cx plus d equals 0, where a, b, c, and d are numbers but a cannot be 0. Note that 3 should be the highest exponent or the degree. Example, 5x cubed plus 3x squared, minus 4x, minus 12 equals 0. Are all these clear, class? Did you get all the concepts of polynomial equations? I hope it's yes. This time, for you to familiarize those concepts, try to do this activity in your notebook. This activity is entitled, Identify Me. Your task is to identify the different parts and types of the given polynomial equations. Next, let us discuss how to find the roots of a polynomial equation using the zero product property. The zero product property says that, if for example, we have ab equals 0, then either a is equal to 0, b equals 0 or both a and b are equal to 0. For us to better understand this concept, let's consider the following examples. Example number 1. Find the roots of the given polynomial equation by applying the zero product property. X plus 3 times x minus 2 times x plus 1 times x minus 1 equals 0. Note that, in zero product property, either x plus 3, x minus 2, x plus 1, and x minus 1 can be equal to 0. To get the roots of this polynomial equation, for x plus 3 equals 0, we will transpose the 3 to other side, which will give us x equals negative 3. In the same way, we solve x minus 2 equals 0, x plus 1 equals 0, and x minus 1 equals 0. So, the roots are -3, 2, -1, and 1. Is it understood? I hope you got everything clearly. Next example, find the roots of the given polynomial equations by applying the zero product property. Quantity x plus 4 squared times quantity x minus 3 cubed equals 0. So, here, as you observed, when there are exponents, we can write them as this. For x plus 4 quantity squared equals 0. This can be rewritten as a pair of x plus 4 equals 0. This also gives us the root of -4 when transposed. Next, for x minus 3 quantity cubed equals 0. This produces 3 parentheses of x minus 3 equals 0, which also gives us the root of 3. Therefore, the roots of the given polynomial equation are -4 and 3. Please take note that, having 2 or more similar roots can be rewritten as 1. That is according to the rule of multiplicity. Are you now ready for another activity? This time, for you to hone your newly learned skills, try to do this activity in your notebook. This activity is entitled, Find My Roots. Your task is to find the roots of the given polynomial equations by applying the zero product property. This time, let's reflect on this question. How can knowledge on polynomial equation and zero product property will help us solve real-life problems and make our decisions? Let's go and see. For the application, the rectangular classroom of grade 10 Malvar at Baconco National High School has an area of 117 square feet. Mr. Dexter, the advisor, said that the length of the classroom is 4 feet more than its width. But he doesn't know what its exact dimension is. With the given information, help Mr. Dexter to find the length and width of the classroom. Let's start solving this problem, brainiacs. In problems involving geometric figures like this, we need to sketch or illustrate it first for us to easily visualize the situation. Next, we need to identify and name the measures or values that we are looking for. Here, we are looking for the values of the room's length and width. With these, we will let W as our width, and W plus 4 as the length, since it was stated in the problem that the length of the room is 4 feet more than its width. Next, we will translate the important information into an equation. We will start by using the formula of area of the rectangle. Note that the area of a rectangle is given by A is equal to length times width. This time, we will now substitute to the formula all the variables and given present on the problem. We now have 117 is equal to quantity W plus 4 times W. This will be the working equation that we will be using for us to solve our missing values. Step number 5, using our working equation, we will now start solving for the missing values. Simplifying 117 equals the quantity of W plus 4 times W, we can have the equation 117 equals W squared plus 4W. Next, we will transpose 117 to the other side of the equation. We now have 0 equals W squared plus 4W minus 117. This equation has the factors of quantity W plus 13 times the quantity W minus 9. Applying the zero product property that we have discussed earlier, we can now get the roots or values of W. First, 0 equals W plus 13. This will give us the value of W, which is -13. Second, 0 equals W minus 9. This will give us 9 as the value of the second W. Since W is the width of the classroom, it does not make sense for it to be negative. So, we will eliminate -13. For the final step, we will now find the values of the room's length and width. For the width, we have 9 feet. Next, for the length, we will substitute 9 OW. So, we have 9 plus 4, and the length is equal to 13. Therefore, we can now say that the length and width of Mr. Dexter classroom is 13 feet and 9 feet, respectively. Alright, we have finally solved the problem, brainiacs. Congratulations! Before ending this lesson, please take note of this. For you to measure your previously learned understanding on polynomial equations and on how to find its roots using the zero product property, you can answer the 10-item test that I've prepared for you on my quizzes.com account. How? Just search or click the link in the video description below. Enjoy! This ends our lesson for today. Thank you, brainiacs. See you on our next episode.